Hello everyone, hope you're doing well. Greetings from a cold and snowy Salt Lake City, Utah. Hope you're all having a wonderful day. I am having a great day because I
You've got mail.
just
You've
got an
got
email.
mail. You've got mail.
Brad R. asks, most of my career has been commercial electrical and I have not been exposed to very many cable types. Could you do a video on the various wire types, for example, XHHW-2, also known as cross-linked polyethylene, RHW-2, URD cable, mainly the uses and codes that apply to them. Thank you for your time. You're welcome for my time, Brad, and thank you for your message. Before I forget, let me address URD cable, because I will forget if I don't do it right now. There is no URD. That's not a thing. URD is just a slang term for underground residential distribution. If you go to the parts store and you say, give me some URD, what you're going to get is USE-2. All right, you're going to get individual conductors plexed together with an optional binder element around them, and that's going to be either triplex or quadruplex. That is URD, it's USE-2. We're going to talk about USE conductors, but in case I forget, they're also newly added in Article 338 in the 2020 code. Take a look at 338.2 for the definition of multi-conductor assembly, I think is what it's called. 338.2 for the definition, 338.100 for some construction specifications. So before I forget about URD, which again I'm going to forget because there is no URD. It's not a thing. So with that said, let's take a look then at Article 310, which of course is where we're going to get the answers to these questions. So Article 310, conductors for general wiring, 310.1, the scope. I always like to start with the article scope whenever possible. And this was revised in the 2020 edition, so it's particularly important that we talk about this. As you know, my yellow underground text is showing a code change. So Article 310 says this. This article covers conductors rated 2000 volts and less, including their types, insulation, markings, ampacities, and use. All right, so the change in the 2020 code is twofold. Number one, they reconfigured and redid Article 310, and quite frankly, they did a great job with it. Article 310 is a much simpler and more user-friendly article than it was in 2017 and previous versions. And one of the big reasons for that is that they limited Article 310 to just 2000 volts and less. Now, let's just be honest for a minute. Most electricians really don't get above 2000 volts. You know, certainly people do medium voltage, but most of us don't. So Article 310 in previous versions of the code had maybe 5 pages of actual requirements and then probably 15 pages of tables, most of which nobody ever used because they were medium voltage or they were really unusual applications. But here's the problem. Because there were so many tables back to back, a lot of people would give up reading Article 310. I mean, how long do you just keep on looking at tables that nobody uses before you give up and you say, well, I guess I've read all of Article 310? Well, that was a mistake because there was material in the back of Article 310 that was pretty important and nobody saw it. So in the 2020 code, we rewrote Article 310. I say we. Let me explain that. Anytime a good code change happens, I say we made that change. Anytime a bad code change happens, I say they made that change. So just kind of a we and they type of a thing. So this is one of those changes that we made. All right, so we limited the scope to 2000 volts and less. What do we do with medium voltage conductors and cables? Well, those are now in Article 311. So if conductors like these are your cup of tea, well, great. It's in Article 311. So this article covers the use, installation, construction specs, and ampacities for type MV medium voltage conductors and cable. All right, so that was kind of a change made in Article 310 in the 2020. Back to 310.1, I want to quickly mention that Article 310 does not apply to conductors that are an integral part of equipment such as motors and similar. So I don't need to look at these conductors on this ballast to see if they're of a type indicated in 310.4, if they're marked in accordance with 310.8, I think. We don't need to be worrying about that. That's not conductors, that's just equipment. So with that said, let's jump into 310.4 because that's where we're going to answer Brad's question. 310.4 Application and construction of conductors. Lots of good information here in table 310.104.4. I need to stop saying 310.104. It was 310.104 for 50 years. Now it's 310.4. Insulated conductors must comply with tables 310.4a and b. And then there's an informational note, and it's worth reading, especially if you're in a cold environment like I am. There's an informational note that says, listen, thermoplastic insulation can stiffen at temperatures colder than 14 degrees F and could deform and become damaged when bent during the installation. So we want to be careful that we're not installing it in too cold of a temperature. Thermoplastic like THHN or THWN, those of us that have installed it in cold temperatures can attest, it gets miserable to work with. And a lot of times what will happen is the nylon will crack and come off of it. Now, I do want to clarify that that's not the insulation. That's just the nylon covering. And damage to the nylon is usually okay. Damage to the actual insulation, of course, is not. Now, I try to cite my sources. Is it just my opinion when I say that damage to the nylon is okay? No, I'm not going to go out on a limb like that unless I can back it up. This is from one of many manufacturers. This one happens to be from Wire. But if you go to the other manufacturers, they're going to say the same thing. They have an FAQ on their page. Is the nylon jacket on THHN for mechanical protection only? And their answer to that is quite interesting. The function of the nylon jacket on any THHN/THWN product is twofold. First, it works with the PVC insulation to provide enhanced resistance to gasoline and oil, so that's important. If you're installing this stuff at a gas station or refinery, somewhere where you need resistance to gasoline and oil, you can't break the nylon outer cover. If you go to 501, I think it's 501.25, maybe it's 501.125, that talks about gasoline and oil resistance for conductors in Class 1 locations. So if you need that gasoline and oil resistance, then the nylon jacket is really important. Let's keep reading. PVC is already resistant to gasoline and oil. Okay, great. Secondly, it provides additional abrasion and damage resistance during installation for the PV insulation on the product. The nylon is not intended to provide any electrical insulation for the product. If the PVC insulation is not damaged, then the electrical integrity of the cable is unchanged, even if the nylon is completely removed. The PVC insulation is not compromised by contact with water, since PVC is moisture resistant. So there you go. The nylon jacket does two things. It gives you gasoline and oil resistance, and it protects the product during installation and actually it helps in the ease of the installation as well. It helps it glide through the product a little bit easier. So if you break the nylon jacket, don't sweat. It's not a problem unless you need the gasoline and oil. All right, let's go ahead and jump into table 310.4a, application and insulation. 310.4a includes the following. It includes conductor temperatures, allowable uses, coverings, and insulation values. All right, so we're going to talk in generalities here for just a moment. Okay, this does not apply to every single cable under the sun, but generally speaking, we can say this with a reasonable amount of accuracy. Generally speaking, if the wire does not have an H in the insulation marking, THHN, THW, and if there's no H's, then you're probably talking about a 60-degree conductor. If there's one H, like THW, that would be a 75-degree conductor. If you have two H's, that would be a 90-degree conductor, THHN, for example. And then if there's a -2 suffix, XHHW-2, THWN-2, USE-2, if you have a -2 at the end of it, that means it's a 90-degree conductor even in a wet location. As we're going to find out here in a minute, there are conductors where the temperature rating of the conductor changes based on whether you're installing it in a dry location or a wet location. So that -2 at the end of it can actually really help us out. Now again, this is just speaking generally. We're talking about THHN, RHH, XHHW, the stuff that we use and install every day. If you want to talk to me about, FEP or MTW, some of the weird stuff, these thumb rules don't apply to those. But for the stuff that we install every day, those are kind of the guidelines for the temperature ratings. If we see the letter N at the end of a conductor, that means it has a nylon outer cover. So THHN, THWN. So what do we know so far about THHN? Well, we know there's two H's, so we know it's a 90-degree conductor. We know there's an N, so we know it has a nylon outer cover. If I see the letter R, like RHH or RHW, that means it's a thermoset insulation. So if I have RHH, we know that that's a 90-degree conductor with thermoset insulation. The letter T means that it's thermoplastic insulation, and that's the stuff you don't want to install if it's colder than 14 degrees F. By the way, you really don't want to install thermoset if it's colder than negative 13 F. So you don't want to do anything if it's colder than negative 13 degree F. If it's colder than negative 13 degree F, you need to be in the truck, right? So anyway, T is thermoplastic insulation. So now we know what THHN is. THHN is what? A thermoplastic insulation rated 90 degrees with a nylon outer cover. So I can use that around gas and oil. U means that it's good for underground. So USE conductors, for example, that would be underground. Or if you have UF or let's see, UF and USE, I think are the two that start with the U. Those are both good for underground. If we have the letter W, that means we're good for a wet or damp location. So THWN, we know that's a thermoplastic 75-degree wet location nylon outer jacket. And then we have X, which is for cross-length polyethylene thermoset. So if we have XHHW, that's a cross-linked polyethylene, but it is a thermoset insulation nonetheless. It's HH 90 degrees, W would mean it's good for a wet location, right? And if it's XHHW-2, then we know it's a 90-degree conductor in a wet, dry, or damp location. All right, so with that in mind, let's go ahead and open up the codebook together, and we're going to look at table 310.4, and we'll really get to the bottom of this. So I'm going to use NFPA link. By the way, if you're not using NFPA link, man, what are you doing? It's only $10 a month for a single user, and it's even less, I think, if it's multiple users. And you get access to every single NFPA standard, not just the NEC and NFPA 70E, but every single NFPA standard that they make. You do a lot of fire pumps and you want a copy of NFPA 20, but you don't want to buy it? Cool, get yourself a copy of NFPA Link. So nfpalink.org. Let's go to 310.4. Sorry, that's the end of my sales pitch. I don't care if you get Link. I don't make any money off of it. But for $10 a month, it's a steal. And you can use it offline now, by the way. 310.4. Let's make that table bigger. And hopefully you guys can see that. Looks like we can. So we can scroll down here. We have MTW, which is like machine tool wiring for a wet location. But I want to spend more time on the stuff that we really deal with on a normal installation. RHH is something that we might deal with. RHH is often used for PV, solar applications. It's also something that that conductors will have a dual listing. They'll have their product listed as one thing and as RHH or RHW. So what do we know about RHH? We already talked about it. It's thermoset, right? It starts with the letter R. Has two H's, so that's a 90-degree conductor. I don't see a W in it though, which means it's dry and damp locations only. You can buy this stuff in 14 gauge right up to 2000 kc mil. It's a moisture resistant, flame retardant, non-metallic covering. If I wanted to put it in a wet location though, I would either buy RHW, which we know is what? Thermoset, wet location, 75 degrees, and you can see that right there. Or I could always buy RHW-2, which is what? Thermoset, 75 degrees, wet location, but the -2, remember, the -2 is 90 degrees even in a wet location. So RHW-2, dry and wet location, good to go. Let's see what else we have. How about THHN? We know what that is. That's heat-resistant thermoplastic. THHN, it's a 90-degree conductor. It has two H's. There's no W, though, so that means it's only good for dry and damp locations. Holy smokes. So what happens when you install THHN in an underground conduit? Remember, the inside of a conduit in a wet location is a wet location, right? 300.5b tells us that, and so does 300.9, and so does the definition of wet location, location comma wet. So can I install THHN underground? No, no, absolutely not. THHN underground or outdoors is a violation. Now, does that mean that you've been doing it wrong your whole career and you're going to be burning down the whole town in a couple of years? No, because when you go to the parts store and you say, hey, give me a roll of THHN, what are they actually giving you? They're not giving you a roll of THHN, they're giving you a roll of THHN / THWN-2, whether you like it or not. Okay, so don't sweat that you're using THHN incorrectly for the last 30 years. THHW, we know what that would be, right? That would be a thermoplastic 90 degrees wet location, 90 degrees in a dry location. So let's take a look at that. It's THHW, which means you can put it in a wet location. But in a wet location, it's only good for 75 degrees. It's good for 90 degrees in a dry location. Okay, interesting. Well, what if I wanted THHW and I needed the 90 degree rating and I'm in a wet location? Well, what you'd do is you would get yourself some THWN-2, which we know is 90 degrees in a wet, dry, or damp location. That's because it's a flame retardant, moisture and heat resistant thermoplastic. You can buy this stuff from 14 gauge up to 1000 kc mil. As we know, it's got a nylon jacket or equivalent. What do we know about TW? We know that's thermoplastic, and we know it's good for wet locations. But notice that there's no H's, so that's only a 60 degree conductor. There's not an N at the end either. Now that doesn't really matter unless you're doing somewhere that requires what? Gasoline and oil resistance. So there you go. We've got UF. You can buy individual UF conductors. Usually you buy it in a cable. And then we have USE and USE-2. Boy, I think maybe my package just got here in the mail. My dogs are my poor man's alarm system. So I think the UPS guy just got here. So hopefully that's my Peter Wright darts practice rings set that I ordered. Looking forward to playing with those. So USE-2 is what? It's good for underground use. It's service entrance cable, dry and wet locations, 90 degrees. And then last, let's take a look at our XHHW, which is a cross-link polyethylene product. It is thermoset insulation. 2 H's means 90, W means wet location, and it's going to be the same concept when we scroll down here to XHWN-2. So we have a cross-linked polyethylene thermoset product. 1 H is only 75 degrees, but that -2 means it's 90 degrees wet, dry, or damp. The W means wet location. The N gives us a nylon outer jacket. XHWN-2 is the stuff, make no mistake. Rated 14 gauge up to 1000. You can get XHHW in sizes all the way up to 2000 kc mil. If for some insane reason you decided you wanted to, go bigger than 1000 kc mil. If you do that, video yourself bending it and send it to me. I would love to watch you wrestle some of that stuff. All right, so that is table 310.4a. So let's look at this conductor. THHN / THWN-2. What do we know about it? We know it's thermoplastic. We know it's 90 degrees. We know we can use it in a wet location at its 90 degree rating, and we know it has a nylon outer jacket or equivalent, so we can wire up a gas station with it, right? That's our THWN-2. What do we have here? Ooh, looks like we have some DLO cable. I don't remember seeing DLO in table 310.4, and that's because it's not there. Okay, what do I do if I have a conductor that's not in table 310.4? Well, the answer is simple. You don't install it. You can't just take a piece of copper, wrap some sort of non-conductive material around it and think that the code recognizes it. That's not the case. Only the conductors that are recognized in 310.4 can be used. So this is DLO. Can't install it. That's why, if you look down a little farther, it says RHH/RHW-2 as well. So when you see DLO cable, and I used to get this question all the time, in the area where I inspected, we had a couple of decent sized industrial facilities, and sometimes they would call when they actually were, getting a permit, and they would ask, they'd say, oh my gosh, I got some 444 kc mil wire. What's the ampacity of it? And I said, well, let's do this in the right sequence. 444 kc mil. Before we figure out the ampacity, let's figure out what kind of conductor it is. And they'd say DLO. And I'd say, oh, well, that's easy. You can't install it. Anything else I can help you with? And of course they'd freak, and I'd say, all right, let's keep looking, and if it says RHH/RHW-2, then you can put it in. Now that still begs the question, what's the ampacity? And until the 2020 code, that wasn't addressed. It didn't give us any guidance in the 2017 and previous versions of the code and to tell us what to do. Now in section 310.15, it actually says for ampacities that are not indicated in table 310.16 or 310.17, then the ampacity can be interpolated using engineering supervision. So get yourself an engineer that can extrapolate the current between 450 and 400 kc mil and figure it out that way. While we're on the subject, let's talk about a couple of other code articles that are kind of worth mentioning. Table 402.3 for fixture wire and table 400.4 for chords are very similar to the tables that we just talked about. So let's go ahead and open our code back up, and let's go to chapter 4. We'll start with 402.3 for our fixture wire. Not too often that we install fixture wire, but we do once in a while, so it's worth understanding at least what it is and how to use the table. If we scroll on down to the most commonly installed types, that would be TFN and TFFN. So TFN is a thermoplastic insulation, like you might have guessed. N is what? Nylon jacket. Perfect. F is what? Fixture wire. 2 F's is what? Flexible fixture wire. So TFN, TFFN are your two most common. They are rated 90 degrees both, so the H thing, you know, the H or the two H's doesn't apply to fixture wire. And then, of course, if we were to scroll down, I've never seen this, or if I did, I didn't notice. We have XFF. What do you suppose that would be? That would be cross-linked polyethylene, right? Is that spelled right? Polyolefin. Interesting. I have never heard the word polyolefin in my life. So, maybe it's not polyethylene. I've always thought it was cross-linked polyethylene. FF is going to be what? Fixture wire that's flexible. And then let's go to table 400.4 for our chords. Scroll on down here. And this is where we're going to find the characteristics for flexible chords. Lamp cord type C, for example. Let's keep on scrolling down here. EV is electric vehicle cable. Might have guessed that one. G is portable power cable. That's worth knowing about. If we keep on scrolling down here, we get into our hard service chords and our junior service chords. Those are the ones with the letter S, right, for service chord. And if we keep on scrolling, we've got SEO, which is what? Service chord. Thermoplastic elastomer. Oil resistant. There's your S, your E, and your O. SEOW is going to mean the same three things plus what? Damp and wet locations. Yeah. Something else that's worth checking out is the permitted uses of the chord. Notice how this table here says pendant or portable. You know, if it doesn't say pendant, then you can't use it in a pendant application. Now, a lot of the chords are rated for pendant applications, but if you were wiring a luminaire, or if you had a cord drop, you know, going to like a wood head box with a receptacle, you better be using a cord that's rated for pendant use. If you're not, it's going to be a violation. So, some little interesting things here in table 400.4. SJ is going to be what? Service junior. So junior hard service chord, not quite as good as service chord. If we keep on scrolling all the way down, we've got hard service chord, and that is rated for what? Extra hard usage. If you scroll all the way to the right, in fact, I'm not certain that you can see it here unless I do that. So there's your extra hard usage on hard service chord SO, SOOW. And there are sections of the code that require a rating of extra hard service. If we scroll down here to the last one that I want to talk about, that's going to be SPT-2. SPT-2 is a flat 2-wire cord, well, 2 or 3 wire, usually it's 2 wire. Kind of a trade name is a zip cord, so it's like a kind of like lamp cord. So that would be your SPT-2, your flat 2-conductor or 3-conductor cord. And then again, we scroll down here and we've got some oddities like vacuum cleaner cord and parallel tinsel cord and things like that. So there you go. That is your table 400.4. The last table that I want to talk about is going to be table 8 in chapter 9. That contains information like circular mill, resistance, and stranding. So let's go ahead and take a peek one more time. We're going to search it this time and go to table 8. We're going to search all of that. And we'll go to table 8. Let's see here. Table 8. Oh, where did it go? Oh, see, I thought that was hyperlinked. My bad. Struck out on that one. Let's go to, in fact, you know what we'll do? We'll just do chapter 9, table 8, which is conductor properties. There we go. All right. I'm going to make myself disappear so that you can see the whole thing. If I have 14 gauge conductors, that is 4,110 circular mil, and that's something that we need to know about in some calculations. You can get it in 1 strand, which we would call solid, of course, and you can also get it in stranded, which is 7 strand. So those are your 2 stranding types. Gives you the overall area of the conductors, and then if we scroll over here to the far right, it gives us our DC resistance for both copper and aluminum conductors. Now, aluminum is straightforward enough. If you're doing calculations, make sure that you're careful about whether you're doing it in thousands of feet or thousands of kilometers. Very easy mistake to make. But what's this business about coated and non-coated copper? Well, uncoated copper is the copper that we all use every day and know and love. Coated copper is coated with what? It's tin. So tinned copper is what we're talking about here in the far right-hand side. As we stroll down to our larger conductors, one of the things you'll notice that changes is the number of strands. You know, if we only had 7 strands for a piece of 4/0, that's going to be pretty tough to work with. So once we get to 1 gauge and larger, it's 19 strands. Once we get to 250 kc mil and larger, it's 37 strands. Once we get to 600 kc mil and larger, well, find somebody that's bigger and stronger than me to deal with that. So with that said, I think we made it through our little journey of 310.4, 400.4, 402.3, and table 8 in chapter 9. I hope you had as good a time as I did, and we'll see you on the next video. Thanks, everybody. Please do be safe. Be sure to like, follow, subscribe, and ring the bell.